All right, intermediate students, I wanted to do a couple of examples to recap for 3B, which is solving systems by elimination, but dealing with word problems. In this one, I will do the Freyer model just to show you how you can continue to use that. It says Kayla School is selling tickets to the annual dance competition. On the first day, ticket sales sold three senior citizens tickets and 5 children's tickets for $70. The school took in $216 on the second day by selling 12 senior tickets and 12 child's tickets. Find the price of a senior citizen ticket and the price of a child ticket. So in this box, we're going to put price of senior and child ticket. Okay. Having said that, don't forget to define your variables. I'm going to say X is senior and Y is child. In the next box, I'm going to write my first equation, and that's going to be the one that I squiggled underneath. Equation 1 will be the information here. 3 senior tickets, so 3 times the amount of a senior ticket, plus 5 kids tickets, so 5 times the cost of a children's ticket, equaled $70. Okay, so that's what this tells me. If it's 3 and 5, I would do 3x plus 5y equals 70. The second day they took in $216. So equation 2 is the underlined stuff. So it's going to be equal to 216. But then it says they sold 12 senior and 12 child tickets. So that would be 12x plus 12y equals that. So now we need to take these two equations and solve them. I'm going to come up here. So I need to set them. So 3x plus 5y equals 70. I always like to set it up as a system. 12x plus 12y equals 216. We are going to use elimination, but when I look at it, nothing cancels if I add them right away. So I'm going to look at my x's, and I see I have a 3 and a 12. If this is a negative 12, they would cancel. To make a 3 be a negative 12, I would multiply by a negative 4. Okay, so I'm going to multiply that entire top equation by negative 4. So I get negative 12x minus 20y equals negative 280. Okay, so again, the strategy for solving a system by elimination is to multiply one of the equations by something to be able to get a variable to cancel. I bring over my second equation, which is 12x plus 12y equals 216. And now that something will cancel, I add those equations together. The x's go away. I have a negative 20y plus 12y equals negative 8y. And negative 280 plus 216 was negative 64. Okay, so I'm combining like terms there, divide by negative 8, and I get that y equals 8. Once I have one variable, I take that and plug it back into an equation. I picked the first one before I multiplied. I could either use the original, I could use the other original, or I could in theory even use the one that I multiplied by negative 4. So I do 3x. I have to remember to put that 8 in for the y, even though a lot of times people put it in for the x. So it's y equals, so I substitute for the y. 3x plus 40 equals 70. Subtract 40. We have to get rid of these steps of algebra. Oops. 3x equals 30. Sorry. Divided by 3. I get x equals 10. Now remember, before we would write it just as the ordered pair, 10, 8. But because it's a real world example, we have to describe what those variables mean. What this means is that I go back and I said x was the senior ticket cost. So a senior ticket is $10 and a child ticket is $8. Okay, so that's what I got for my two values. So again, we can use this Freyer model, but as we get more and more comfortable with it, we won't necessarily write it out this way. I usually think about the question, but then I identify my variables, and then I would usually just jump right to this end part, set up my two equations right on top of each other, and then solve. Let's do one more example just so that we can continue to practice writing equations and also see elimination one more time. This time it says Mimi and Carlos are selling cookie dough for a school fundraiser. Customers can buy a package of chocolate chip cookie dough and gingerbread cookie dough. Ming sold 8 packages of chocolate chip and 12 packages of gingerbread for a cost of $364. Carlos sold 1 package of chocolate chip, 4 packages of gingerbread for a total of $93. Find the cost of 1 package of chocolate chip cookie dough and 1 package of gingerbread cookies. Okay, so rather than using the Freyer model, even though it's here, I would just underline that question so I remember what I'm looking for. I would still identify my variables. We're talking about chocolate chip, cookie dough, and gingerbread. So I'm going to identify X as chocolate chip and Y as gingerbread. But now instead of writing my equations in each of the boxes, this visual helps me remember I need to come up with 2 equations. The first thing I see is Ming, and he sold 8 packages of chocolate chip and 12 packages of gingerbread. I would write that by doing 8x plus 12y. When he sold that, he made $364. So that would be an equation for Ming. Carlos, on the other hand, sold 1 package. Oops, I should probably use different. Carlos sold 1 package of chocolate chip and 4 gingerbread for $93. So if I want to write an equation for Carlos, I would say 1x, because that's 1 cookie dough, plus 4y for gingerbread, and his should equal $93. Okay, so I usually like to just write them right underneath there, but I always identify my variables, set up my system of equations, and now I solve. Now, when I look at this, all my bigger numbers are on top, so I need to look at the bottom. In theory, I could multiply the bottom equation by a -8 to get my x's to cancel, and that would just make my numbers pretty big. There's nothing wrong with doing that. Having said that, I see that I have a 12y and a 4y, and so if I multiply 4 by -3, that would also eliminate something, this time the y's. So sometimes you have a choice as to whether or not you want to eliminate the x or the y. If that's the case, I usually use my smaller number because I like to keep things smaller. So when I did this problem, I carried over the top equation, 8x plus 12y equals 364. And I chose to multiply the bottom equation by -3. So I get -3x minus 12y equals, and -3 times -93 gave me -297. Again, you could have multiplied the bottom equation by -8 as well. All right, when I go to add these though, 8x minus 3x gives me 5x, the y's cancel, and then 364 minus 297 was 85. Divide both sides by 5, and I got x equals 17. Once I get that, I pick either equation. Now, many times I use the top equation, but once again, this time, I see that the bottom equation, that original 1x plus 4y equals 93, has the smallest numbers, so I chose to use that. So 1 times 17 plus 4y equals 93. I would not have had to write the 1 times 17, so 17 plus 4y equals 93. Subtract 17, 4y equals 76, divided by 4, and I got y equals 19. Last but not least, we need to remember that we are actually trying to find the cost of each package. The X was the chocolate chip. So chocolate chip cookie dough costs $17. That's this one. And then the Y was gingerbread. So gingerbread cost $19. Okay, so there's a couple more examples of what you saw in the video last night, and that's solving word problems using elimination. Again, the review is writing a system of equations with word problems. We did that in 4.2b, but then now we also are reviewing solving elimination, which is what we did yesterday. Remember, your job now is to go to the 4.3b Pearson practice, and you must submit it by the end of your class period today to be counted present. Okay, so please go there right now and get that taken care of. Thanks so much, and I will see you back in class on Thursday. Don't forget, Wednesday is also an asynchronous day, so take care of your Pearson work that day. Have a good one. Bye.